So our goal out here is to understand empirical formulas. Okay, so empirical formulas are basically the smallest whole number ratio of the atoms in any particular compound. What does this really mean? So let's take a very interesting molecule which we deal with in our daily lives, water. So what's the whole number ratio of hydrogen is to oxygen? Well, as you can see, it's 2 is to 1, right? If you take another molecule, hydrogen peroxide, you'll see the whole number ratio is 2 is to 2 of hydrogen is to oxygen, which means that you can actually simplify this further. So it's 1 is to 1. Okay, that means this is the molecular formula of the compound. However, the empirical formula is just going to be HO. Okay, because you're just taking the simplest whole number ratio. Okay, let's take two more examples. So let's say you talking about benzene. Benzene has a molecular formula of C6H6, meaning carbon is to hydrogen is 6 is to 6. If we simplify this further, then it should be 1 is to 1. So therefore the empirical formula, I'm going to abbreviate empirical formula by EF, should be CH. And let's take another look at a compound. Let's talk about acetylene. Acetylene is C2H2, and if you try to find out the ratio again between carbon and hydrogen, you should have 2 carbons is to 2 hydrogens, and the empirical formula is the simplest whole number ratio, which is 1 is to 1, and therefore that should also be CH, same as benzene. So as you can see, empirical formula just gives us the ratios of the atoms. So therefore, if we just go based on empirical formula, therefore benzene and acetylene should really be the same molecule. But in fact, it is not, because they're combined in different whole number multiples of the empirical formula. Therefore, empirical formula is just an easy way to knowing the percentage composition of each atom in a particular compound. Okay, so if you notice very carefully, the percentage of carbon is to hydrogen is going to be the exact same as the percentage of carbon is to hydrogen in acetylene, even though benzene is a different compound than acetylene. So normally when problems are given to you in these kind of requiring you to use empirical formulas, what they'll give you is the percentage composition of the elements in the compound, and then they'll ask you to determine the empirical formula. Okay, so let's see how you do this. Okay, let's take an example. Okay, so if you look at exercise 3.10, okay, now exercise 3.10 in your book is basically it basically tells you that there is a compound, and this compound contains 83.5 grams, contains 33.4 grams of sulfur, and the rest is oxygen. But the total mass of the compound, so the total mass of the compound happens to be 83.5 grams. 5 grams. Okay, so it tells you that the rest is oxygen, meaning if you take 83.5 and subtract 33.4, which is the mass of sulfur, you should get the mass of oxygen. Okay, that should be 83.5 minus 33.4, which should give you 50.1 grams of oxygen. Okay, so now we're going to write down what we have. So we know that the compound contains sulfur and oxygen. What else do we know? Well, we know that the mass of sulfur in this compound is 33.4 grams and the mass of oxygen in this compound is 50.1 grams. Okay, so what you need to find out is the number of moles of sulfur. For that, you can find out the molar mass, or the atomic mass of sulfur in this case. Atomic mass of sulfur. If you look at the periodic table, the atomic mass of sulfur happens to be 32.065. And then the atomic mass of oxygen is 15.9994 grams. Okay, so what you want to find out is the number of moles of sulfur present in this compound. So moles of sulfur should be equal to, should be equal to 33.4 grams of sulfur divided by 32.065 grams per mole of sulfur. Okay, there you go. Which should be 33.4 divided by 32.065 should be 1.0416, and there are some other numbers, but really we're only concerned with three significant figures, so I'm not going to write those out. Moles of sulfur. Do the same for oxygen. Moles of oxygen. That should give you 50.1 grams oxygen divided by 15.9994 grams per mole. Which gives you 3.13136, and let's keep going, moles oxygen. Okay, so now we know the moles of sulfur present in 33.4 grams, and then we know the moles of oxygen present in 50.1 grams. So all we got to do is take a simple whole number ratio of this to be able to arrive at the empirical formula. So I'll take a fresh sheet of paper. So if you write sulfur is to oxygen, and then you write 1.0416 is to 3.13136. You don't worry about the rest. So if you take a ratio of this, this is approximately equal to 1:3. If you see, because what we want to do is we want to round this up to a whole number. So round to a whole number, okay? Therefore, the empirical formula of this compound should be 1 sulfur and 3 oxygens, and there we go. Why? Because this 3 came from this and 1 came from the 1 sulfur. So let's check to see if the answer is correct. That's exercise 3.10. Okay, so we look at the back of your book. SO3, that's correct. So we're good with this. So now let's look at another problem just to seal those concepts in. So let's look at problem 3.65 in your book. 3.65. Okay. Okay. So